How can you know that reality is real? What if everything you see is an unimaginably complex simulation, where every particle obeys code and the laws of physics are just lines of a program? Today, some physicists claim there's growing evidence for that idea. And if they're right, then everything around us from stars to consciousness itself might be a digital dream, a computation running somewhere beyond time and space. The simulation hypothesis was long dismissed as science fiction, but now mathematics, information physics, and quantum mechanics are stepping in. Since the late 20th century, scientists have been finding hints that reality behaves like a computational system, and that energy and information may be more deeply interchangeable than we ever thought. Philosopher Bostrom framed the famous argument in 2003. If civilizations ever reach the point of being able to create entire simulated worlds, they'll probably make millions of them. Statistically speaking, it would then be almost impossible that our world is the original. But Bostrom only offered a hypothesis. Today, physicists are trying to find experimental traces of a simulation, and that's where things get truly strange. In 2012, a team at Fermilab proposed a test. If spacetime is quantized, it should have a grain, like pixels on a screen. This discreteness might limit the energy of particles over vast distances. Searching for such artifacts is the mission of the Holometer project. It tries to detect the holographic noise of the universe, the tiniest fluctuations caused by living inside a computational grid. Results so far are inconclusive, but one thing is clear. For the first time, we're truly searching for digital fingerprints in the fabric of the cosmos. Physicist John Wheeler once said, "If from bit, everything is from information. Matter itself is the manifestation of data." Modern information physics supports this far beyond what Wheeler imagined. Every electron carries a finite number of bits. Even black holes can store information on their surfaces like enormous flash drives of the universe. From this comes a startling implication. If everything is data, there must be an encoder behind it. The laws of physics could be the algorithms processing that data. In recent years, physicist Melvin Vopson from the University of Portsmouth has claimed that information isn't an abstraction, it's the fifth state of matter. He calculated that data could have real mass. One bit weighs roughly 10 kilograms. If that's true, then the universe must contain an immense amount of informational mass distributed across its particles. And if so, that's a nearly literal proof that everything we see is made of information, meaning reality itself might be a computation. Another path of reasoning comes from quantum mechanics. We know that a particle exists in multiple states until it's observed. But what or who performs the observation? If consciousness or measurement activates reality, it's eerily similar to rendering in a video game. The world appears only when someone looks at it. In this sense, the brain or awareness acts as a processor that completes the computation. But then arises the paradox. If the observer is part of the simulation, who observes the observer? The cosmic microwave background, the very oldest light we can see, might hold clues. Some physicists have suggested that if spacetime is a digital grid, then the microwave background should show subtle symmetries or periodic patterns that standard physics can't explain. Data is still scarce, but research teams are mapping the sky millimeter by millimeter. Any recurring energy cycles could be the first signs of a digital texture in the universe. The scientific community remains cautious, yet interest is growing. This hypothesis, astonishingly, can be tested at least indirectly. If it turns out to be true, unsettling questions follow. What is free will if every thought is a line of code? Does morality exist in a computed world where good and evil are just different algorithms? And above all, why run such a simulation? To study the rise of life? To test the endurance of consciousness? Or are we simply an emergent byproduct of a natural process that manifests digitally instead of biologically? Of course, there are critics. Physicist Sabine Hossenfelder insists the simulation idea is unscientific because it can't be verified. Even if we did find glitches, we never prove they were code rather than new physics. Yet even skeptics admit the hypothesis is valuable because it reshapes the way we think about knowledge, information, and awareness. Even if we're not in a simulation, exploring the idea helps us understand reality itself more deeply. Some researchers have even speculated how to detect the computational limits of the universe. If it runs on finite resources, it may show errors like bit flips in memory. Astronomers have already noticed mysterious data anomalies while studying pulsars, perhaps just noise, but possibly tiny cracks in cosmic computation. Another idea: time might slow at extreme energies. If particle energy stops increasing despite acceleration, like hitting a performance ceiling, then the hypothesis could become tangible. How do we distinguish the real from the simulated? When everything we perceive passes through our brains, the brain itself filters, edits, and simulates sensory input. Maybe the simulation isn't outside of us, it's inside the observer. Some neuroscientists argue that the human mind creates a private virtual reality for survival. If that's true, then every person is a small simulator, and the universe is a vast network of these processors computing their own existence. There was a time when the atom was thought to be indivisible. Then we found electrons, quarks, and perhaps even deeper structures. Each generation discovered that what seemed solid matter was actually another level of code. So maybe the question, are we in a simulation, is the wrong one. The world could be both computational and real, like a wave and a particle, depending on how you look at it. Reality isn't the opposite of simulation, it's just another layer of description. Today, science stands at the edge. Information theory, quantum computing, and cosmology are converging. If someone eventually uncovers the formula that describes the entire world as an algorithm, we'll have to admit we've found the code of creation. And then the same haunting question will return, as at the beginning. Who pressed enter? And what happens if that someone decides to press delete? Simulation or not, what matters isn't the answer, it's the search. Every question about the nature of reality makes us part of a larger computation. As long as we keep asking, the program continues.